Hi, I'm Dean Kershaw, Kershaw Instrumentation. We're here today to talk about our semi-automatic viscometer model SAV-09. The SAV-09 is actually an interface for either our falling rod viscometer model FRV-2000 or the older Luray viscometer. For our demonstration here today, we have one of our FRV viscometers set up here. If you'd like a more detailed discussion on our FRV-2000, you can see our product video on that device. But essentially, our falling rod viscometer consists of a stand. We have a start sensor, a stop sensor. We have an elapsed timer. The elapsed timer is connected to a computer via a USB connection. That's how the semi-automatic viscometer gets the data. We also have a USB temperature probe that monitors the temperature of the collar during our test, and that USB temperature probe is plugged into the computer so that our interface can acquire the temperature data. So without further discussion on the hardware, I would like to get into the software aspect of this, and then we'll actually run some tests and get some data. So for starters, to start this application, we simply click on the SAV icon, and it starts out with what's called the interface discovery. And first thing it does is goes out and looks for the elapsed timer via the USB port and make sure that that is functional. And then it also goes out and finds a temperature probe and make sure that that is functioning properly so that we can complete our test. Now, once the application starts, this SAV-09 screen will appear as shown. And we have a couple product tabs that we're going to talk about here. The first one is entitled Product Information. You have 4 entries there: product number, lot number, report title, and comments. They are all optional. You could leave any or all of those blank if you prefer. The only one that I would recommend that you fill in is the report title, because when you print out the results of a test at the end, a report title is going to be displayed on that report. So you may want to put company name, customer name, product name, project, whatever, as your report title, so that you'll know what it's referring to when you generate a printout. The second portion of this second tab is the test tab, which looks like so. And we're going to talk about these items. The data sets. This is how many different weights are we going to use to run our test. Normally we want to run at least 3 different weights. Sometimes we may want to run 5 or 6. The more weights that we have, the more accurate our results are going to be. To kind of speed up our demonstration here today, I'm going to set this to 3 weights. But also the next box below is how many drops we want to do for each weight. And to speed up our demonstration here, I'm going to change that to only 1. Normally we would want to do more than 1 drop for each weight, but to aid our discussion here, I'm going to change that to 1. Over here we have the rod and collar serial number. Now if we have a number of different rods and collars in our laboratory, each one of those can be calibrated with this system, and we simply come over here and we'll get a drop-down menu, and it will include all of the rods and collars that have been calibrated, and we would select the one that's in use. Now in our particular case here, we only have 1 rod and collar set that's calibrated with this system, and that's number 0, so that's the one that I've chosen to use here today. We have 2 different algorithms. We have the ASTM algorithm, which simply uses the math that's specified in the ASTM 4040 specification. We also have a custom one that we have entitled KII. We're going to use the ASTM algorithm for our demonstration here today. I had mentioned to you earlier that we have a series of weights that we sell with these systems. Normally they're nice even numbers: 100 gram, 500 gram, 800 gram, and so forth. But if you have some custom weight that you want to use for whatever particular reason, you would actually enter that in here as the user weight. For example, let's say I wanted to use 1,340 grams, just arbitrarily picking a number. I would key in 1,340 in the box next to weight number 1, and that would be that's where I would be able to do that entry. Now the next tab is entitled Data Set, and if you come over here, you'll see there are actually 8 data sets, but there are only 3 of them that are alive. The other 7 are grayed out. Now the reason for that is because over here on the test tab, we specified that we wanted 3 data sets. So here's where I'm actually going to put in the weights that I'm going to use. For example, my first drop, I want to use 1,000 grams, so I'll pick 1,000 from our drop-down menu. The second drop, we're going to use 1,500 grams, so I'll select that from the drop-down menu. And the third one, I want to use 2,000, so I'll select that from the drop-down menu. Now you'll notice in that drop-down menu down at the bottom we had these users 1, 2, and 3. User 1, that would be that 1,340 that I entered a couple minutes ago over here in the test area. So anyway, I've selected 1,000, 1,500, and 2,000 grams as my 3 drops. We're going to do only 1 drop for each of those 3 weights. The last tab is our temperature tab. Now it's asking me if I want to compensate the data for the temperature, and I want to keep that active. I can turn it on or turn it off by clicking in the check box. What that's going to do is if I have that active, if the temperature is slightly off from the 25 degrees centigrade, then it will automatically compensate in the algorithm for the change in the temperature. Now there's also another feature over here that allows us to abort the test if our temperature is out of specification, and in this case our temperature tolerance is 1 degree centigrade. So for example, if I have a specified temperature of 25, which I've just set there, and I have a tolerance of 1 degree, and I have this turned on, if our temperature goes below 24 or above 26, then it's not going to let us complete our test. Because I'm not hooked to a temperature control here, I am going to turn that feature off, but we are going to compensate for temperature. So without further ado, let's go ahead and actually run a test, and I'll show you what the results are. So we come up here to the test button, we start our test, and it's asking us, do we wish to continue? Yes, we do. And it's telling us to apply, right here it's telling us apply 1,000 gram weight and execute the drop. So I'm going to come over here, put 1,000 grams on the rod, and now we're going to do our drop. And you see our elapsed timer is counting because we have crossed that upper sensor. And we have a full time of 19.44 seconds. And if you look over here on our what says SAV mode 1 right here, it says that our drop time was 19.44, which of course is what we measured on the elapsed timer. Our weight was 1,000 grams because that was the weight that we put on, and our temperature was 23.24 degrees C. Now it's telling us to put 1,500 grams on, which is our second weight that we had chosen to use. So I have pulled the rod up and I'm preparing this to make another drop. Okay, this time I will put on 1,000, 300, and 200 for a total of 1,500 grams as my system has told me to do. Now we're going to go ahead and pull the trigger, and our rod is dropping and our elapsed timer has started, and I would expect to get a lower number than the previous number because we've got more weight. So we've passed the low sensor and this time we had a fall time of 11.49. And again, if we go up here, it says set 2 of 3, fall time 11:49, weight 1500, temperature 2324. So now I'm going to pull the rod back up again. And I'm going to move some of this ink down to the bottom to prepare for our test. And now I will apply 1,000, and I'll put another 1,000 on top of that to make it 2,000, because our application is telling us apply 2,000 gram weight and execute the drop. So I will go ahead and pull the trigger, and we passed the top sensor. Our elapsed timer is timing. Now we've passed the lower sensor. This time we have a fall time of 7.85, which is lower still, which is what we would expect because we have a higher weight. Now if we come over here and we look at our application, it says set 3 of 3, fall time 785, weight 2,000, temperature 23.33, and so forth. But if we look over here, we can see that our viscosity is 58.58 poise, has the yield value, the shortness ratio, and so forth. Now at this point, we can store this information by clicking on our little drive symbol up here. And what it will do is it will store all of the fall times, temperatures, and weight values for future use. Or we can print it if we go over here to the little printer, and it'll print a report. Now upon printing the report, it will look like the display that we have posted on the board there. You get a better look at that. Now on the report, it has all of the statistical information that we entered on that first screen, and then it also has the viscosity, the yield value, and this portion of the report has all of the fall time, weight, and temperature information. So this concludes our demonstration on the semi-automatic viscometer interface.